Hello, my name is Christy Scales, and this is my week 8 submission for Data Architecture and Business Analytics Final. In recent feedback with the C-suite team in our data architecture department, the team has expressed a need for concern to update our system for a more cost-effective and simpler program to a non-relational database. So after we surveyed the executive team, we decided to go ahead and make that switch due to ease of use, flexibility, and costs that it could incur by doing so. So to better serve our stakeholders, the goal is to implement a new database management system that can be utilized across the organization quickly and efficiently. A little bit more about the database that we work in. Our database consists of Kansas City crime event information, and it includes information on the demographics of Kansas City crime event victims, their relationship with offenders, details of the crimes committed against them, as well as data related to domestic violence, if firearms were involved, the type of abuse that's included, as well as the relationship between the offenders and the victims. Now, along with this data, some of the columns and rows that you'll see in here involve with 911 dispatch information that involves the type of events, the police beat that the incident occurred on, and as well as the geographical information that comes with it, where the incident occurred. Not all information is available to all users. There are precautions in place to prevent people seeing it who don't need to be aware of some of the data. So precautions are in place to allow for permissions based on role and job responsibility and for security measures. So providing some pros and cons for relating to this database for the move from relational to non-relational. One of the main pros that we have is that they're scalable. Non-relational databases are very, very scalable. And they make it easier to handle growing daily volume criteria for our crime event database. Crimes do occur daily, so this database does continue to grow daily. So it'd be easier to scale for this data that continues to grow. One of the other awesome things about non-relational databases for this particular system is that they're more cost effective in terms of hardware. And so the scalability and the distribution capabilities of non-relational databases can really reduce the need for expensive high-end maintenance hardware that we have to keep on the premises. One of the cons, I think the biggest con that we'll have changing this database to non-relational will absolutely be the learning curve. Anytime we switch or make a change of any kind related to data, there's always a learning curve. And switching to a non-relational database might require a significant change for our developers and our team, as well as our internal and external stakeholders, as well as the people who are accustomed to this relational database that we currently use. Our developers will have to acquire new skills and learn new techniques to catch on to this database if it's something they're not already familiar with. That could be a drawback when working with our backlog. Having to learn a new skill could be a problem if in the event that the backlog gets backed up with production issues. Another main concern that we have would be the data inaccuracies. Sometimes with non-relational databases, they can tend to be more challenging because of the constraints provided for them. So they often lack built-in support for integrity constraints and causing relationships. This could cause data discrepancies and inaccuracies from time to time if we're not careful. With those pros and cons in mind, I do want to recommend that we switch to a non-relational database for the Kansas City crime events database that we just built. The advantages of it being flexible, the performance, the cost effectiveness, and the fact that it's very agile will help our environment, and it will help our current team and development staff achieve faster and quicker success. Thank you.